AB is the diameter of the circle ABC with center O. AD is the tangent to the circle at A, and ADC is equal to an angle ADC is equal to 56 degrees. And here we have this diagram, and our goal is to calculate angle BCA. So what angle are they really talking about? Well, let's look at it. They say BCA, so we have B here, and then we have A here. So B, where's C? B, C, all right? So B, C, and A. So we're referring to this particular triangle, all right? So B, C, A. So the angle that they are really looking for is the one that is in the middle, all right? So they want us to figure out, okay, what is the measure or what is the size of this angle right there? This particular angle right there. Now, in order to figure what is the size of that angle, the same angle right here, what we're gonna use is we're gonna apply this theorem. And the theorem is angles in a circle, angles in a semicircle rather. And it says the angle in a semicircle is 90 degrees. And so if we look at this diagram, we see this angle in the semicircle and it's 90 degrees. And the same thing is here, right? We have the diameter AB. And so this is a semicircle, and this part is also a semicircle. And we have right here the angle in a semicircle, and we know that the angle in a semicircle is 90 degrees. So that means that angle BCA is 90 degrees. And so let's move on. We have to determine the size of angle ABD. Now for angle ABD, what are we looking at, right? What are we looking at? So angle ABD, all right, so we have angle A, so we have, this is A, and then this is B, where's B? B is here, and then this is D, all right? So we're zeroing in on this particular triangle, but which angle do they want in particular? They say angle A, B, D, so that means that they want the angle that is in the middle. And so that means that what they want is they want this particular angle right there, all right? So this is the angle that we're looking for, angle B, all right? And so what do we know so far? Well, we do know that this is 56 degrees, all right? And we're trying to figure what is this angle B. The question is, what is this angle right here? Like, what is this angle, all right? Now, this angle, if you notice carefully, that this right here is a tangent line, all right? So this is a tangent line. And this angle, this side, this line AO, the line segment AO is actually a radius. So this is the radius, and then this is a tangent, all right? So the angle between the radius and the tangent is 90 degrees. So that means that this right here is 90 degrees. All right, so this is 90 degrees. And so what do we have, right? We have that we could use this rule, which angles in a triangle add up to 180, because we know that this is 56 degrees. We know that this is 90 because it's the angle formed between the tangent line and the radius. And so this is 90. And so we need to figure out what is this one. But we know that this angle plus this angle plus this angle must add up to 180 because they're in a triangle, and angles in a triangle add up to 180 degrees. And so in order to figure out our answer, we're gonna add 90 and 56. We're gonna add them, and then we're gonna subtract that sum, or we're gonna take away that sum from 180. And so what we have is 180 minus 90 plus 56. 90 plus 56 is definitely 146. So we have 180 minus 146. And 180 minus 146 is definitely 34 degrees. And so that means that this angle right here, angle B, is definitely 34 degrees. Okay, next, what we need to do is we need to determine what is the size of angle CAD, right? We need to determine the size of angle CAD. And so when we look at angle CAD, what do we have, right? So C, A, and D, all right? So this is what we're looking at, right? So CAD. So the angle that we that we're trying to figure out, or the angle that we're trying to find, is the one that's in the middle. So we have this angle right there. I'm going to put an asterisk right there to let us know which angle we're talking about. So we're talking about this particular angle. In order for us to figure out what this angle is, right, we're going to use the alternate segment theorem. And the alternate segment theorem states that the angle that lies between a tangent and a chord is equal to the angle subtended by the same chord in the alternate segment. And so if you notice this particular example, we have this angle, theta, and so we have the chord, the angle that is formed between the chord and the tangent, that's theta, and that's going to be equal to this angle. This angle is subtended by this chord, right? And it's subtended by the same chord that forms an angle with the tangent, all right? And we know that theta is subtended by this chord because the legs of theta rest on this chord or lies on this chord. And so in order for us to solve or to determine what is this angle, we are going to use the alternate segment theorem. Now remember what B is, right? Remember what B is. B is 34 degrees. That's what we figured out on the previous question. So B is 34 degrees, all right? Now, what does the rule says? The rule says that this angle, theta, that is formed between, this is the chord and the tangent, this same angle that is formed between the chord, this chord, and the tangent is going to be equal to this same angle that is subtended by this same chord. And we know that this angle is subtended by the same chord because the legs of this angle, all right, the legs of it, let me use green. The legs of this angle rests on this chord, right? So the legs of this angle rests on this chord. So that means that this angle, right, is subtended by this chord. And so we have this angle right here that is formed between the chord and the tangent is equal to this angle that is subtended by the very same chord that we have in yellow. And so that means that these two angles are equal, which means that if this is 34 degrees, that this must also be 34 degrees, all right? And so what do we have? Well, we have that angle CAD is equal to 34 degrees, and that's because of the alternate segment theorem. And that's the answer to this question.